Hey everybody, today's lesson is 1-6, comparing and ordering real numbers. We can compare two values by using inequality signs like the less than and greater than. Okay, so we're going to compare a few values down here. It is important to get them into the same form. So if I'm looking at A, I have 2 and I'm comparing it to the square root of 8. Well, hopefully you'll remember that the square root of 8 falls in between the square root of 4 and the square root of 9. Well, the square root of 4 is equal to 2, and the square root of 9 is equal to 3. So if I were to just kind of approximate what the square root of 8 is, I know it's 2 point something. Since the square root of 8 is very close to 9, I can approximate that it may be around, 2.8. Either way, which one is greater? The square root of 8 is going to be greater than 2. When I'm looking at my two negative numbers, I've got a negative 1.5 and I've got a negative 5 over 2. Again, I need to get them in the same form to be able to compare them. So I like decimals, so I'm going to keep the negative 1.5. I'm going to look at negative 5 over 2. Well, if I divide 5 by 2, I'm going to get 2.5. And because it's negative, so is my decimal. And again, just chop down the tree if you need to. 5 divided by 2 is 2 with a remainder of 1. Bring down the 0 and 2 goes into the 10 5 times. Okay, out of these two, which one is greater? I want you to think about the number line. Okay, so I'm going to put 0 over to the right, and then I'm going to have negative 1, negative 2, negative 3. Okay, so if I'm looking for negative 1.5, it's going to be about right here, and negative 2.5 will be about right here. So out of those two, which one is greater? When you're dealing with negative numbers, the more negative it is, the less that it is. So in this case, negative 1.5 is greater than negative 5 over 2. Okay, see, I have 12.5 already in decimal form, and then the other one is the square root of 145. Well, I know the square root of 145 is barely over our perfect square of 144. The square root of 144 is 12, so square root of 145, 12 point, maybe 1. Okay, so we know that that 12.5 is greater than 12.1. Okay, you're going to see some directions in the homework that are going to ask you to order things from least to greatest or greatest to least. You might have some other words and phrases that are used instead. So another way to say least to greatest is ascending. So you may see it say, list the following values in ascending order. Or it could say increasing order. You may even see it saying from minimum to maximum. Okay. Pause if you need to finish writing all of that. For greatest to least, we would have basically the opposite of what we have above. So the opposite of ascending is descending. Opposite of increasing is decreasing. And the opposite of minimum to maximum would be maximum to minimum. Pause if you need to finish writing that down. Okay. So, like I was discussing earlier, when I'm comparing values, they need to be in the same form. You did a lot of changing things from fractions to decimals and decimals to percents back in 6th grade and 7th grade and earlier in this unit. To change a fraction to a decimal chop down the tree. So 1/3, the 1 will fall into the house, the 3 will be on the outside. 3 goes into 1 0 times, but it goes into 10 3 times. And you'll see that you have a repeating fraction going on. So in decimal form, this will be 0.33 repeating. If I were to change that to a percent, remember, if we're going from a decimal to a percent, we're going to the right 2 places. So I'm going to move my decimal point 2 places to the right. 1, 2. That's going to give me 33%. Or even 33.3 repeating percent. Okay. With 0.2, in order to change that to a fraction, look at the place value that it's in. That is in the tenths place value, so that is 2/10. It doesn't ask us to simplify, but we can simplify. The largest number that goes into both 2 and 10 is 2. 2 goes into 2 1 time. 2 divides into 10 5 times. In percent form, to go from, again, if I have my DP, to go from a percent to a decimal, I'm going to move my decimal 2 places to the left. And I meant that we are going from a decimal to a percent, so we're going to move it 2 places to the right. Sorry, a little tired today. If there's nothing there, after you move the decimal 1 place, you have to add a 0. So that's where that 20 comes from. Okay, so if I have 50%, we are moving from a percent to a decimal. So again, use the DP in that order, because when you're going from a percent to a decimal, you're going to move that 2 places to the left. And that's going to give you 0.50 or 0.50. To make that into a fraction, since I have 50 there, I'm just going to look at the 0. That is in the hundred spot, so I have 50 over 100. And 50 over 100 can be simplified down to 1 over 2, because 50 goes into 50 1 time, and 100 is divided by 50 2 times. Okay, so with 2/3, to go from a fraction to a decimal, need to chop down that tree. I'm going to use this over here so I can have some space to do it again. So 2 divided by 3, 2 falls into the house, 3 on the outside. 3 goes into 2 0 times, but it goes into 20 6 times, and that gives me 18. Subtract that, and I see that that 2 is going to be coming down every time. 3 goes into 26 times, so I have a repeating decimal again. So I have 0.66. Make sure you have the repeating line on there. In percent form, I'm going to move that decimal over twice, and that's going to be about 66. And I'm going to go ahead and put the repeating decimal out there, 66.6 repeating, or if I round it, around 67%. What place value is that 5 in? That 5 is in the hundreds, so 75 over 100 will convert it to a fraction. 25 goes into 75 3 times, and 25 goes into 100 4 times. Now think about it as quarters. How many quarters is 75 cents? How many quarters is $1? To convert 0.75 to a percent, I'm going to move the decimal point over 2 places, and that will give me 75%. With 12.5%, I need to move that decimal 2 places to the left, and that's going to give me 0.125. In order to make it a fraction, I need to see what place value that 5 is in. It's in the thousandths, so 125 over 1,000. Now, most of us don't see the largest value that will go into both 125 and 1,000, but we do know that at least 25 will go in there. So 25 goes into 125 5 times, and it goes into 1,000 40 times. But you may recognize that you can still simplify that, because 5 will go into both 5 and 40. 5 will go into 5 1 time, and it will go into 40 8 times. So that is 1 over 8. Okay. 2/5, if I chop down the tree, 2 falls into the house, 5 on the outside. 5 goes into 2 0 times, but it goes into 20 4 times. So our answer for the decimal form is 0.4. In percent form, I'm going to move that decimal 2 places to the right. There's not enough room, or there's not enough values there, so I'm going to add a 0, and that's going to give me 40%. I'm going to do the same thing with 1.5. Move that decimal over once, move it over twice. I have to add a 0, so that's 150%. If I put this in fraction form, that's going to be 1 and 5 over, well, that 5's in the 10th spot, so 1 and 5 over 10, which can be simplified to 1 and 1/2. Okay, so hopefully you can remember those. We're going to use those values, keep going back to those fractions a lot today, and we're also going to do some estimating. So if I'm comparing these that we have down here, I have a negative 7 over 8. Well, if I had negative 8 over 8, wouldn't that be about a negative 1? Okay, so not quite negative 1, but we're just going to round to negative 1. And then I have negative 0.5. So which one is greater? Remember, on your number line, your positive numbers would be over here. We have 0. We would have negative 1, negative 2. And the closer you are to 0 on the negative side, the greater that number is. So negative 0.5 would be about right here. Negative 7/8 would be about right here. So negative 0.5 is greater. Okay. For number 2, we have pi squared, and we're going to compare it to the square root of 49. Well, pi we usually approximate as 3.14, which is very close to 3. So if I have pi squared, what is 3 squared, or 3 times 3? Approximately 9. Okay, and the square root of the square root of 50 is very close to the perfect square of 49. And the square root of 49 is 7. So basically what we're doing is we're comparing 9 to 7. Which one's greater? 9 or our pi squared. For number 3, I have a percentage and I have a fraction. I want to make them both decimals. So in order to make negative 60% into a decimal, I'm going to move the decimal 2 places to the left and make that negative 0.60. Now negative 3/4, that is going to give us, you can chop down the tree, or you can just kind of remember that that's going to give us a negative 0.75. If I have 3/4 of a dollar, 75 cents. So which one is larger? Again, the less negative it is, the greater that it is. I always look for the greater value. Number 4 is an excellent question. Looks like a great FSA type question. So what I have to do is I have to add 5 plus the square root of 60. Well, the square root of 60 is not a perfect square. Square root of 60 falls in between the square root of 49, which is 7, and the square root of 64, which is 8. It is closer to 64 than it is to 49. So I know that my value is probably around 7.7. Okay, so if I were to take 5 and add to it 7.7, that's going to give me about 12.7. Okay, for over here on 4 plus the square root of 63, I see that it's almost the square root of 64, and the square root of 64 is 8. So if I were to just kind of guess and say 4 plus 7.9, or even I could have rounded to 8, it doesn't matter, and I added 4 plus 7.9, that would give me 11.9, very close to 12. So which one is greater? 5 plus the square root of 60. So again, these don't have to be exact numbers. We're kind of using our number sense to help us out with this. Last question on this page. It took Kiara about 35.25 minutes to finish chores on Saturday, while her brother Derek took 35 and 1/6 minutes. So I'm going to write down Kiara's time and Derek's time. Okay, and we have to figure out who finished the quickest. Most of the students that I've had have said Derek. Let's check and see if they're right. So they both have 35 as their whole number, so I'm going to convert this 1/6 to a decimal. So let's see how that works. I'm going to chop down the tree. The 1 falls into the house. 6 goes into 1 0 times, but it goes into 10 one time, with a remainder of 4. I'm going to add that, bring it down, and 6 goes into 40 6 times. And I've done enough at this point to see that my decimal is going to be repeating. So Derek finishes his chores in 35.16 repeating minutes. So who got done the quickest? Yeah, the classes were right. It's Derek. Now here's where we get to use those vocabulary terms, and there's a lot of questions here. So what I'm going to do is I'm going to jump around a little bit. Actually, I'm going to do the left-hand side. We're going to do 6, 8, and 10. To list the following in descending order on this one, number 8, we're going to go from least to greatest, and number 10, we're going to go in decreasing order. Okay, so descending order means that we are going to start with the largest number all the way down to the smallest number. But again, before I can do any of these, I need them to be comparable. I need to be able to compare them to each other. So I'm going to put them all in decimal approximations. The square root of 121, hopefully you recognize that that is a perfect square. And square root of 121 is 11. So I'm going to just kind of write that up there so I can remember it. Pi squared is 3.14 times 3.14. Again, I can approximate it. 3 times 3 is around 9. Then I have the 11.1 there. And then the square root of 130 is larger than the square root of 121, so I know it's going to be more than 11. And it actually falls in between square root of 121 and 144. I'm thinking it's very close to the halfway mark. So I'm going to say, I don't know, maybe about 11.3, 11.4. Okay. Either way, I know that that's my greatest number that I have there. So descending order means largest to smallest. So I'm going to put them in their original form. The square root of 130 is our largest, followed by 11.1, followed by the square root of 121, because that's equal to 11. And then finally, we have pi squared. So again, largest to smallest. This is the reverse. This one is least to greatest. So we're going from smallest or most negative to the largest. Okay, so the first one's already in decimal form for us, so that's nice. The second one is a perfect square, but it has a negative sign. So the square root of 25 is 5. So the negative square root of 25 is a negative 5. Okay, then I have negative 5 and 1/5. Okay, so hopefully if you look on the front page, you'll see what that decimal equivalent is, but if not, I'm just going to do real quick over here. It should work out very nice and very quickly. 5 goes into 10 2 times. So negative 5 and 1/5 would be negative 5.2. Okay, and then 11 divided by 2, or half of 11, would be 5.5. Since it's negative, my answer would be negative 5.5. Okay, so again, we're going from least to greatest. So in the case of them all being negative numbers, we need the most negative number will be the smallest number. In this case, that's going to be negative 5.5. In its original format, the smallest number in here is negative 11 over 2. Okay, I need to look for the next smallest number, or the next most negative number, which would be a negative 5 and 1/2. I'm sorry, negative 5 and 1/5. Followed by, I have negative 5.025 or negative 5. Okay, well, negative 5.025 is more negative than negative 5, so that's going to be our next number. And then our last number is the negative square root of 25. The last one, number 10, list the values in decreasing order. So again, this is going to be the greatest to the least. Okay, I hope that you know that 5.5 in decimal form is 5.5. If not, chop down the tree. Square root of 26 is very close to the square root of 25, which is a perfect square that gives you 5. So I'm going to estimate that this one is like 5.1. 5.8 is already in decimal form, so that's nice. Let's go ahead and chop down the tree over here. 5 goes into 31 6 times because 6 times 5 is 30. Add a 0, and 5 goes into 10 2 times. So that's going to give me 6.2. All right, so in decreasing order means I'm going to start with the largest one, which would be 6.2. in its original format, 31 over 5. Followed by the next largest, which would be 5.8. Then 5.5. And finally, the square root of 26 is their smallest guy. Then you may have some questions where they're giving you different temperatures or different depth levels of the ocean or something like that. So here we're given different temperatures of towns, and we're going to write them in ascending order according to their temperature, so smallest to largest. Okay, so we have Chillyville, which is the negative square root of 48. Well, I know that negative 48 falls in between the square root of negative 36 and the negative square root of 49. It is almost a negative 49, so I'm going to say it's almost negative 7. It's very close. Icetown is the negative square root of 65. Well, the negative square root of 64 would be a negative 8, so the negative square root of 65 is just barely a little bit more than that, so I'm going to keep it at a negative 8. Okay, and then negative 7.5 is fine. It's already in decimal form. And then I have a negative 22 over 3. Well, 3 goes into 22 7 times. The remainder of 1. Bring that down, and 3 goes into 10 3 times. So that's going to give you a repeating decimal right there, so around negative 7.3. Okay, so I've got all my answers that I need. Again, ascending order means to go from the smallest number to the largest. So I need the most negative number. And it asks us to list the towns, so let me do that. So the most negative number would be negative 8. So that's going to give us an answer of Icetown. Okay, then the next temperature would be the second most negative number, which would be Shivertown. Love these names. I'm sorry, Shiverton. After that, we would have Chillyville left and Little Flake. Chillyville is around negative 7 degrees. Little Flake is negative 7.3. So that would make Little Flake the next one. And then the warmest out of all these would be Chillyville. It has the highest temperature. And that's it. So when you're working on your homework, you might want to write a list of perfect squares over to the side or have them out like I have written there. They kind of help with your approximations. And do your best.